Thank you for joining me today to learn about dyslexia, which is the most common cause of reading, spelling, and oral and written expression difficulties. My name is Heather Fleming. I am the mom of a dyslexic middle schooler. When he was diagnosed in third grade, it was after 3 years of academic, social, and emotional difficulties. I moved with him to Denver so that he could attend a school for bright dyslexic students where his academic skills could be strengthened. During that time, I completed extensive training in how to teach reading, and I also tutored at the school. I am currently enrolled in a master's program in reading science, which focuses on how literacy skills are acquired by the brain, what can get in the way of those processes, additional training in the rules and structure that govern the English language, as well as how to directly and explicitly teach that content to mastery, and then how to use assessment data to fill skill gaps. My partner Carrie Roden and I were honored to work with the Department of Education, the Wyoming Department of Education last year, to write the K-3 Reading Assessment and Intervention Amendment and to produce the related implementation guidelines. We then founded YLIT to raise money for gen ed and special ed teacher training in reading for those teachers who think they would like to add additional tools to their toolbox. So today we will talk a little bit about the biology of dyslexia, the neurobiology, what dyslexia might look like in your classroom, some of the impacts of reading difficulties, how you might think about screening for dyslexia and supporting dyslexic students, and then a little bit about what research-based instruction and intervention is. First, a few facts about dyslexia. It comes as a surprise to many people that dyslexia is, in fact, the most common cause of reading, writing, and spelling difficulties. It has been shown to impact up to 20% of the population, to varying degrees, of course. We also now know that it is genetic. So dyslexia does not impact the parts of the brain that are responsible for critical thinking and reasoning. Dyslexics tend to be very creative, big-picture thinkers. It is known that dyslexics rely more heavily on the right hemisphere of their brains, and that the right hemisphere is connected more to art and creativity. So it is theorized, though it has not been proven, that the right hemisphere of the dyslexic brains are simply more developed from more use. Dyslexia does not discriminate. It occurs equally in boys and girls and across socioeconomic classes and languages, regardless of whether they are alphabetic languages or not. Now, I will say that while the skills of boys and girls may be impacted in the same way, the way that boys and girls may react to this and behave in the classroom can be very different. So I'd like to address some dyslexia myths. Dyslexia is not a vision problem. Parents waste a fortune on colored glasses and overlays and vision therapy that do not help. If any of these things help a student's reading, it is not dyslexia. Dyslexia is not seeing letters or words backwards or upside down. Again, it is not a vision problem. Dyslexia is not outgrown, and it is also, as we discussed earlier, not related to IQ. It is not caused by poverty or lack of reading in the home, and it is not something that can be treated with medication. So now I want to offer some information about dyslexia and the brain. I'm a big fan of morphology, or the study of words, because almost 100% of our multisyllabic words have Greek or Latin parts. So dyslexia literally means a difficulty with language or words. Dyslexia is what is referred to as a language-based learning disability that impacts language processing tasks. Here are examples of the language processing tasks that dyslexia impacts. Phonological or phonemic awareness. This is a student's ability to manipulate oral language, not yet connected to letters. Their reading will be impacted, their fluency, and therefore their comprehension. Their spelling is often impacted. Handwriting can be very messy and outsized. Their ability to write and speak in an organized, concise way can also be difficult. Taking notes and copying things down can be very hard for dyslexics, as is word retrieval. That experience that we've all had of having the word on the tip of our tongues but not quite being able to get it. So I will show you images of this in a minute, but non-dyslexic brains do those language processing tasks that I just talked about in the left hemisphere of the brain. What we know from a variety of types of brain imaging is that dyslexic brains primarily do these tasks using the right hemisphere of the brain, which is not meant for language processing and does these things very inefficiently. So what's going on in the dyslexic brain? Brain imaging can study a variety of characteristics. It can study density and size and blood and water flow, as well as electrical activity. These studies show that in the left hemisphere of the dyslexic brain, there is actually typically less gray matter, and it shows that the connections between the areas of the brain used for reading tend to misfire. Neurons are coated with something called a myelin sheath. It is kind of like the plastic coating on the outside of an electrical cord. It keeps the electrical signals running smoothly. When the myelin sheath is thin, the signals are disrupted. Here are the 3 areas of the brain used in reading. Of course, this is a bit of a generalization. No brain activity is this cut and dried, but this gives you an idea of where these different tasks are occurring. To orient what you are looking at, the gray oval is the front left side of the brain. The gray oval represents where oral language processing happens, again, when the sounds are not yet connected to letters but are just oral. The green area of the brain is where phonics happens. This is where the letters and sounds are connected. Both of those areas interact with the red area of the brain, which is where once a word is quickly and accurately recognized, it can be retrieved from. A few slides ago, I mentioned that when we look at images of a non-dyslexic brain performing reading tasks, we see activity in the left hemisphere. So these top 2 images are of a non-dyslexic brain, and you can see that in the left hemisphere there's a lot of activity. In the right hemisphere, less activity. When we then look at the bottom 2 images, which is of a child with reading difficulties or dyslexia, we see a lot of activity in the right hemisphere and not as much in the left hemisphere. And again, remember, the right hemisphere is not as efficient in doing language processing tasks. The really cool news is that the brain can be rewired. Neuroscience shows us that intensive evidence-based interventions can actually rewire the dyslexic brains to move back to using the left hemisphere where language is meant to be processed. And this is a picture of some of this incredible research that has now been replicated many times. The top 2 images show a dyslexic kindergartner's brain before intervention occurs. So you can see, again, not a lot of activity on the left side of the brain where we would normally expect to see it, but a lot of activity in the right hemisphere. Now look at the bottom 2 images. After intervention, look how much more activity is occurring in the left hemisphere of the brain. We still have activity in the right hemisphere. We'd expect to see a little, but not nearly as much as we did up here. So this shows you that the earlier and the more intensively we can intervene with children who have reading difficulties, the more we can rewire their brains. So we talked about the language processing tasks that may be impacted by the differences in dyslexic brains. Frequently, we also see these areas impacted in dyslexic children. Working memory is the ability to manipulate information stored in your short-term memory that comes in through your eyes or your ears. For example, if I asked you to remember a phone number, that would be stored in short-term memory. If I asked you to recite it to me backwards, that is working memory. Processing speed is the efficiency with which different areas of the brain can process and retrieve information. A student with slow processing speed may have trouble taking in, processing, and retrieving information. You can imagine how this might impact a student's ability to connect letters and sounds efficiently. So now I want to talk a little bit about what dyslexia might look like in your classroom. If you have a child who has difficulty identifying and manipulating individual sounds within words, this is a red flag. For example, if you say to a kindergartner, say cat without the k, what word do you have? That is a red flag. These children also have difficulty determining if words rhyme or producing rhyming words. They also will have difficulty segmenting words into syllables verbally. Dyslexic children will perform below grade level in foundational reading skill tasks and also reading. The reading, when they start to read in first grade, will be slow and robotic. It may be inaccurate. It will seem like it takes them a ton of effort. They may look at the first sound in the word and then guess the rest of it. They have persistent difficulty as they continue through grades 1 and 2 with multisyllabic words and with sight words. Their reading often lacks intonation or awareness of punctuation or prosody. Sometimes they skip entire words or whole lines of text, and they often mix up the small words like articles. In terms of spelling, as you know, it is normal for new spellers to continue to spell phonetically. But when this seems persistent, or when it seems like it's happening with a child who seems otherwise bright and it's a little bit confusing to you, that is also a red flag. So the spelling may be phonetic. It may reflect a phonological or oral misinterpretation of word spelling. There may be confusion, again, persistent confusion with similarly spelled words. And often you may see words that are spelled correctly in spelling tests are incorrect in free writing. And part of this, again, is because if they are using the right hemisphere to do language processing, it doesn't do those tasks efficiently. So they may be able to spell a word in a spelling test, but if they're trying to write a paragraph, they can't focus on spelling and handwriting and content and punctuation all simultaneously. I wanted just to show you an example, and I'm sorry this is a little blurry, of a dyslexic's spelling test. Now, their actual letter formation is not terrible, but as you can see, most of these spellings are very confused. Some of them are phonetic, some of them are misinterpretations of how sounds are spelled. For me, handwriting, if it's coupled with difficulty reading and spelling, is a very visible sign of dyslexia. It's actually a subset called dysgraphia, or difficulty with writing. And I'd like to show you some examples of that as well. This is my business partner, Carrie Roden's daughter's handwriting. She's in 3rd grade. This says, "Have a happy Halloween." Another example of her writing. "I hope you are not busy tonight. Can I keep my tooth and can I have money too? From Eva to the Tooth Fairy." This is another example of a child who is having tremendous time both spelling and just simply getting his hand to put the symbols on the paper that he wants. This is not laziness. This is dyslexia and dysgraphia. Often these children will have difficulty with written expression. They may or may not have as much difficulty with oral expression, but their written expression will tend to lack organization and punctuation and just generally seem maybe simple in compared to the thoughts you think that they probably have. This is an example of what I mean by that. The spelling, the handwriting, the spacing, the content. As I said, oral expression may or may not be impacted. To the extent that it is, I often say that when a dyslexic student tells you a story, it goes on forever. It is not linear, and there are a ton of rabbit holes, and you will often observe that they have trouble distinguishing the main ideas from details that are less important. These kids will almost invariably have trouble with note-taking and copying things, typically because of a combination of difficulty with handwriting, but also maybe some working memory and processing speed challenges. They have trouble looking at what's on the board, remembering it, bringing it back, and then writing it on the paper while still actively listening, for example. You will often see this with these children, that sort of it's on the tip of my tongue feeling, or they will describe a word like it's red and has wheels and you pull things in it and they're frustrated because they can't pull the word. Or they will mispronounce entire syllables or letters in words. So for example, instead of lawnmower, you might hear lawnlower. We know from science that when children have trouble reading, there are specific skill deficits that need to be filled. They may be decoding deficits, they may be vocabulary deficits, they may be background knowledge deficits. But kids don't just catch up. We have to identify and fill these skill gaps. Let's talk briefly about the importance of screening for dyslexia and being able to recognize the signs of dyslexia as a teacher. As I showed you, the correct interventions can rewire the dyslexic brain to make them more efficient at their language processing tasks. What we also know from research is that if we do this before about age 9, we see a lot more movement to left hemisphere activity, which is what we want to see. After about age 9, we see areas of the right brain light up more, so we're seeing a little more compensation than actually remediation to the left hemisphere. So this tells us why we need to identify kids at risk and intervene as early as possible. So I want to point out, having suffered through this with my own child and with other of my advocate friends' children, students who have learning disabilities like dyslexia have a three times greater risk of attempting suicide. These are very bright kids who know that they are failing, and it really crushes their sense of who they are. Unidentified reading difficulties typically often become behavior issues. So kind of you get to the 3rd grade and the child begins to act out. Sometimes these look different between boys and girls. In my experience, boys tend to either be disruptive or act as class clowns. Dyslexic girls tend in general to turn inward a little bit and not draw attention to themselves. So this is an important myth for me to address. There is a myth that dyslexia cannot be diagnosed until 3rd grade. This is unequivocally not true. Those who are at risk for dyslexia and other reading difficulties can be identified as early as preschool. Dyslexia can be formally diagnosed as early as 1st grade. So there are 3 buckets of information that you can use to determine if a student is at risk for dyslexia. Of course, you have your foundational reading skill screening and assessment data. So we should be screening K through 3 for foundational reading skill to see if children are at benchmark. There are also good student screening questionnaires that should be used, as well as family screening questionnaires. Because it's genetic, family screening questionnaires are often very powerful tools. So students at risk for dyslexia typically do not meet grade level benchmarks in, as we discussed, phonological awareness, phonemic awareness, so oral language manipulation. Phonics, kind of letter sound combinations, learning their letters. Being able to read or decode words, but also nonsense words. And we give them nonsense words because we want to know if they've memorized words or if they are actually putting the sounds together with the symbols. We want to test their oral reading fluency. How quickly and how accurately are they reading words at what grade level? We want to know something about their reading comprehension. We also want to know something about how quickly they can name objects. This is something called rapid automatic naming, which many broadly available screeners do, and this tells us something about their processing speed. So the question we always receive is, what skills at what grades do we screen? And this, again, you will have access to this presentation, but this is a chart which just broadly tells you what should be being screened at what grades. Of course, if you have a struggling second or third grader, you want to screen all of these skills. These are links to tools that can be used to screen and progress monitor. And these are links to both child and family screening questionnaires that are short and very, very useful. So in closing, I would like to say a few things about evidence-based instruction. I want to start with a quote from Louisa Moats and Carol Tolman, who are reading researchers. Reading is not natural, which is something that a lot of teachers are taught in teacher prep programs. So their quote is, "The myth perpetuated as fact that people learn to read naturally just by being immersed in print results in misguided instructional practices. Children need to be directly and explicitly taught to master the sounds and rules and structure of the English language. Using pictures or context to guess a word, skipping the word and coming back to it, reading the first sound and guessing what a word might be, are not evidence-based reading strategies. The only cue a child should ever be given is, look at the letters, say the sounds." Further to that point, in order for children to learn to read, they must first understand that spoken words are composed of sounds or phonemes that can be manipulated into words, and that these sounds or phonemes correspond to letters in written form, which is phonics. Here's a graph that shows you what happens to a child's reading level if they have not mastered the sound-symbol relationships of our language. As you can see, the yellow line shows children who never master that sound-symbol relationship, and that their reading levels out at about a third grade level while the other children continue to progress. Again, this is why we need to identify and intervene early. So characteristics of evidence-based instruction. This is what decades of cognitive neuroscience research has shown is the most effective way to teach reading to all children, not just dyslexic children, but to all children. Instruction and intervention must be explicit and comprehensive. It needs to be directly taught. It needs to be sequential, with using a good scope and sequence. The skills need to build so that it's cumulative. The work needs to be diagnostic and prescriptive. We need to use data to identify and fill skill gaps. There needs to be sufficient initial and distributed practice of skills. And we need to use data to inform instruction. Many commercially available reading programs are lacking in guiding teachers about how to explicitly teach, in providing a scope and sequence, and in providing enough initial and distributed practice. So this is a fantastic resource for either reviewing or for learning more about evidence-based instructional practices. We will be producing additional videos that demonstrate each of these being taught in a gen ed classroom so that you can see them in practice. This is a teacher favorite. It lays out the scope and sequence of foundational reading skills from sounds to phonics, and you can see in the middle where the sounds meet the letters. Thank you so much for your time today. If we can support you or your school in any way, please reach out to us.